Hello students, we're going to be looking at another topic on our mathematics class, which is linear programming. Under this linear programming, we are going to be looking at inequalities and solving examples under inequalities using our signs and representing our solutions on the graph. So we have our interactive content here that will serve as a guide for this class. Now, we have under inequality, we have some symbols that we take note. So out of those symbols, we need to understand some of them. Like we have here, this sign is for greater than, and we have this to be for less than, we have this to be greater than or equals to, and we have this to be less than or equals to. We have seen the definitions there, and we have examples to illustrate what we have here. And that leads us to graphing an inequality. So when you are graphing an inequality, you are trying to represent the solutions of your inequality on graph instead of what? Number line. So we can actually use number line as well to represent solutions of an inequality. Now we have an illustration here. This illustration is telling us that whenever we have our inequality to be less than or greater than, then we have on our graph a line that is not that is demarcated. But when we have to be less than or equals to or greater than or equals to, our line on our graph is not demarcated. Now we have grouping and inequality. So what happens when we just have just one inequality and we want to place our solution on the number line? Look at this. We have example when x is greater than or equals to 3. So we should represent that on a graph. Now, if you want to do this, you have to convert the inequality sign here, which is greater than or equals to equals to, so that you can get a definite equation solution. So by so doing, x greater than or equals to 3 can actually change from the greater sign than sign, we change to what? X equals to 3. Now, if you want to now represent that on the graph, note we only have value for x, which is x equals to 3. And for our graph, we always have our y-axis and we have our x-axis. So if you have, look at what we have here, we don't have any value for y-axis, we only have value for x-axis, which is 3. So we can read, we have an illustration of that here. Look at this, this is the x-axis, and we have this to be our y-axis. So under our x-axis and our y-axis, we have the positive side and we have the negative side. Same applies to the x-axis, positive side and the negative side. So our x equals to 3 is going to be falling on our positive side, which is ranges from 1 to infinity. So if we are drawing our own graph, we can decide to add more than 5. But on this example graph here, we are stopping at 5. So if you are to shade now, you see that we are having what here? Greater than or equals to. So you have to have a thick, straight line. Assuming the equals to sign is not there, then we have to have a demarcated straight line. So we place our straight line on 3, which is s greater than or equals to 3. So this is an illustration of how to solve an inequality with just an inequality sign, and we have an example here which is s greater than or equals to 3. So if you look at it, this unshaded part of this graph is the solution set for this inequality. Now let's go to activities. We want to drag the symbols here. What is the sign for equals to? The sign for equals to, we have this as the sign for equal to. Not equals to have this sign. We have this sign for not equal to. Okay. Now is greater than. What's the sign for greater than? This is going to be the sign for greater than. Then what of greater than or equals to? So we have this sign for greater than or equals to. Then what of less than? The sign. This is the sign for less than. Then we have less than or equals to. We have this as the sign for less than or equals to. So let's check. Now let's look at the next activity that we have here. Okay, a graph presentation has how many axes? How many axes? We have 2 axes which we have made mention of. We have y-axis and we have x-axis. So we have 2 axes, and these are what? We have our y-axis, we have our y-axis, and we have our x-axis. Okay, Okay, the arrangement is the other way around. So we have our two axes here, okay? So we have our x-axis and we have our y-axis. So, okay, now let's check. So the arrangement is cool. Now let's look at the next activities that we have here. Y-axis of a graphical representation can be represented on what? We can represent our y-axis on what? On vertical line. So we can represent our y-axis on the vertical line, and our x-axis can be represented on the what? Horizontal line. So let's check. Okay, now x greater than or equals to 3 can be written as x equals to 3 while solving linear equality using graphical representation. Yes, that is true. Okay, because we've solved something like that in our earlier discussion. So now let's look at when we have more than one inequality. Look at this example that we have here. On a pair of axes, shade the region which satisfy this inequality y less than or equals to x plus 2. So if you look at what we have there, we have both x axis and we have what? Both y axis. So we want to get our x axis and our y axis, and we then plot on the graph. Now if we want to do this, we need to pick an arbitrary point of 0 for x and 0 for y, so that we can get a solution for y and we can get a solution also for x. So if you place an arbitrary value, then our less than or equals to sign changes to equals to, so that we can solve as a normal equation. So now we can have it to be y equals to x plus 2. So we have our arbitrary point, which is 0 and 0. When x is 0, what is y? So let's do that. When x is 0, x equals to 0. So what is y? Well, that implies that in this equation set, wherever you see 0, wherever we see x, we put 0. So we have y equals to 0 plus 2. So what is 0 plus 2? So y equals 2. So when x is 0, y is 2. Now the same thing applies to when y is 0, what is x? So whenever you see y here, we replace it with 0 and we calculate for x. So we have 0 equals to x plus 2. Now, for us to get x, we bring x to the other side, right? And it changes to what? Minus. So we have minus x equals to 2. So we don't need a negative value for x. Now we need what? We need a positive value for x. So we can actually divide both sides by minus 1. We divide this side by minus 1. So minus can cancel minus 1 here. And this will becomes minus 2. So we have x equals to minus 2. So we have y equals to 2 and x equals to minus 2. So if you want to plot on our graph, let's quickly sketch our graph. This is for our positive value of y2, 3. That's y-axis. Okay. Now for the x-axis, we have 1, 2, 3. We can have as many as possible. Then our negative 1, minus 1, minus 2, minus 3. And we have minus 1 for the negative axis of y, minus 2, and it can continue like that. Now let's look at what we have solved. When x is 0, this is the arbitrary point. X is 0. What is y? Y is 2. So we shade here. Okay. So when y also is 0, this is our arbitrary point. What is x? X is minus 2. So if we are to stretch a straight line, we are drawing our line to be on this point. So now we have our equation to be y less than or equals to x plus 2, and that is the solution set for this diagram. Now these parts here now, this part, if we are tracing this part, if we trace and trace this part here is the shaded part of the inequality, and the other part here that is not being shaded, based on the diagram we have here, is the solution set for that inequality. Now let's look at the next examples and exercises that we have here. Okay, now graphing more than one inequality. What happens when we have more than one equality? Several inequalities can be graphed on the same axis. So when we have more than one equalities, we can actually plot them on the same graph. Now, if the region which satisfy each inequality are left unshaded, then a solution can be found which satisfy all the inequality, that is, the region that is left unshaded by the inequality side. So I want us to quickly use this as illustration. If you look at this is a demarcated line. So this can be less than or greater than. This is also a demarcated line, so this can also be less than or greater than, and we have a demarcated line. This one is telling us that we only have a solution set for x alone. So it can be x less than or x greater than whatever we have here. It can be 1. Let's assume this one is 1. So it's going to be x less than or greater than 1. And for this one as well, if you look at it, it's also a solution set. So this is just like we're having y less than 4 or y less than 5. And how did I deduct that? Can't this was 1, 2, 3, 4, 5. So we only have five boxes. So that implies that each boxes here is standing for 1. The other 1, 2, 3, and that's how it goes. So let's look at the next slide and let's have this work example here. Okay, now if we have this on the pair of a x-axis, leave unshaded region which satisfy the following inequality. So we have to solve this inequality. Now let's solve and let's see what we have here. For the first one, we have x less than or equals to what? 2. So if we have to solve that, x less than or equals to 2, the inequality sign changes to equals to. So if the inequality sign changes to equals to, so we only have x equals to 2. And now for the next one, we have y less than minus 1. So since we only have a value for y, then we have the greater than changes to what? It changes to equals to. So we have y equals to minus 1. Now for the next one, we have y less than or equals to 3. So the inequality sign also changes to equals to. Then we have y equals 3. Now for the last one, we have y less than or equals to x plus 2. So we need to find an arbitrary point 0, 0 for x value and y axis. Now let's solve for x. When x is 0, what is y? So we have it here. We can now change this one to y equals to x plus 2. So when x is 0, what is y? So we have y equals to 0 plus 2. So we have y equals to 2. So when x is 0, y is 2. Now when x is when y is 0, what is x? So we have 0 equals to x plus 2. So we are bringing our x to the other side. It changes to minus x equals to 2. So because we don't need a minus sign, we need x exactly. So we are going to be having a minus sign transfer to the other side. So we have x equals to minus 2. We can also divide by a minus 1. We divide both sides by minus 1 so that the negative will cancel negative on the x axis. So now we have the solution set for x equals to 2, y equals to minus 1, y equals to 3, and y equals to 2 and y equals to minus 1. So let's quickly draw our graph here and let's have what we have here. So for the y-axis, we only have 1 to 3. So we have 1, 2, 3. That's for the y-axis. Okay. Now for the x-axis, the positive side, the highest value that we have is what? 2. So let's have 1 and let's have 2. You know. Now for the y-axis, what are the values that we have here? On the x-axis, the negative side, we have minus 1 and let's have minus 2. Now for the y-axis, we have minus 1, right? So we have minus 1. You can say have minus 2. Now the first one we are plotting when x equals to 2. So we come to this. This is the x-axis. So when x equals to 2, so we don't have any given value. But remember, we have x equals to x less than or equals to 2. So we are going to be having a tick value. So this one is for x less than or equals to 2. Now the next one is y greater than minus 1. So we come here, y greater than minus 1. We are going to be having a dotted line on the minus 1 line for y axis. So this one is for y greater than minus 1. Now the next one we have y less than or equals to 3. So we come to the y axis, the positive side, and draw a thick line. Why? Because we have the equals to 3 on it. So we have a thick line and we have our y less than or equals to 3. Now the last one that we are going to be having is what? When x is 0, what is y? So when x is 0, y is what? Y is 2. Okay. Now when x is minus 2, what is y? Y is 0. So when y is 0, x is minus 2. So on that note now we draw. Okay, we draw. Since we are not using the graph, that's why it's not straight. So this one is giving us y less than or equals to x plus 2, and that's the line. Now if you look at this, If you want to, all this side is shaded, all this side is shaded, all this side must be shaded because we have already plot a graph on it. We have already plotted a graph on it. So the solution side for this inequality is this side of this graph that is not shaded. So all this side we have already plotted something like this, so is shaded. So the solution side for this equality side is the circle side, which is the center side that we have not plotted anything on. So that gives us the solution to that inequality set. Now let's look at we have an illustration here under linear programming. Linear programming is a way of finding a numbers of possible solutions to a problem given a numbers of constraints. It can also serve as a method of minimizing a linear functions. It can be in two variables, it can be more than two variables. Now, what we are talking about is that when you are having a word problem and we want to represent it with using inequality size and representing our solution on the graph, then linear programming comes in place, and we can actually minimize that problem, or we can and that's the basic method for linear programming problem. So when we are trying to find a solution to word problem under inequality, then we make use of what? Linear programming. So we have an example here. It's a word problem. We are going to be interpreting them, and we have the solution represented on the graph. So we are working that out. Now let's look at the problem that we have there. They said the number of a feed farm with width is we have W to represent width. So width is represented with W, and the number of feet planted with the corn is we have C to represent corn. There are, however, certain restrictions which governs how many feet we can plant of each. Now, there must be at least 2 feet of corn, and there must be at least 2 feet of wheat, and not more than 10 feet are to be sown with wheat or corn. So we have a constraint there, and let's try to look at it. Numbers of feet the farmer plants with wheat, and the numbers of feet he planted corn on. Now, for corn, the first restriction is that there must be at least a feed with 2 corn. The second condition is what? At least 2 feet of what? Of wheat. And the third condition for this farmer is what? At least we have more than 10 feet of both wheat and corn. So for us to represent that with linear inequality, at least means what? At least that implies that it must start with the smallest value, which is 2. So let's represent C to be corn and W to be wheat. Now, having that, wheat is going to be what? W, and corn is represented as C. So the first condition there is what? There must be at minimum feed that contains what? 2 corn. So we are that's going to give us corn less than or greater than or equals to 2. That's the first condition that we have. The second condition is that we must have at least 2 feet of wheat. So that implies that we must have 2 minimum. So that is also going to be wheat greater than or equals to 2. That's the second condition. And the third condition for this farmer is that we must have wheat and corn that is not more than what? That is not being sown or more than 10 feet. So the maximum that we can have on that field is what? 10 feet of wheat and corn. So it's going to be wheat plus corn. We have less than or equals to 10 because it must not be more than 10. Now let's interpret this and we represent our equation. Now for this one, we can represent, let the W be the y-axis. Y-axis is going to be the W. Okay. Now the x-axis is going to be the corn feet. Okay, so for the first condition, we have x, we have c greater than or equals to 2. So if you want to represent that, we can say c equals to 2. That's the first condition to represent on our graph. Now, the second condition is we have 2 feet of width. So we are going to have w equals to. And the next one we have corn feed and width feet that must not be more than 10. So we have equals to 10. Now, we have to set an arbitrary point for C and W, because C is our x-axis and W is our y-axis. So we have 0, 0. So when C is 0, what is y? So wherever you see C, put 0. 0 plus W equals 10. So W will give us what? 10. And now when W is 0, what is C? So it's going to be C plus 0 equals 10. So we are C equals 10. Now, if you want to represent that on the graph, we have already have an illustration here on the graph. For the first one, it's going to be what? C equals to 2. That is our x-axis. So you look at it, you see, we have C equals to 2. And it's going to be what? A thick line. Why is it thick? Because of the equals to sign that we have there. We have C greater than or equal to 2. So we have this thick axis on that. Now for W equals 2 as well. So we have a thick line because we are having W greater than or equals to 2. Now for the other one, we have this C equal, when C equals 10, W equals 10 as well. So we are placing W to be 10, which is we have this, you see the point, and also C equals 10. So this unshaded region is the solution set for this inequality. Now, that leads us to the past question that we have here. We are going to be solving this past question together. It's actually a number line question, and let's just look at it. Now, we have this number line. If you look at this, this is what? This sign is telling us that it is greater than, and this point is not shaded, so it's strictly greater than the equals to sign is not illustrated. So for this number line, it can be represented as what? N greater than. You see, the point is indicating minus 1. So it's going to be N greater than minus 1. And this leads us to the end of our class. We want you to subscribe to our channel for the full interactive content of this class, which is www.edubbey.com. Thanks for listening. See you next time.